I just did a second backup, just so you know.
Hey, this is Mark and Derek in the background here. We're going to be starting up in about 2 more minutes. So getting ready to start the day. Be right back with you. Everybody can see what's going on. Mm-hmm.
faster than their competitors, their innovations fueled by an infinite supply of open source. While most open source is good, some is not, and all of it goes stale over time. 200,000 per year. That's how many open source components the average company consumes to build mission-critical applications. Properly governed, these components are a tremendous source of energy for accelerating innovation. Uncontrolled, they lead directly to security breaches, legal risks, and developer waste. In today's world, companies are desperate to develop software faster, but also stay in control. To do this, organizations must minimize tribal friction caused by cumbersome security gates, and instead promote tribal trust with lightweight security guardrails and DevSecOps automation. Sound impossible? It's not. It's Sonatype. Sonatype's Nexus platform automates open source governance and delivers DevSecOps. It's universally intelligent and knows more about open source than anyone else in the world. And it integrates into your favorite DevOps pipeline tools early and everywhere. Nexus policy controls unite developers and security professionals on the same team and empowers them to continuously identify, manage, and remediate open source risk without slowing down innovation. Today, more than 150,000 organizations rely on Nexus to automatically harness all the good that open source has to offer. Welcome DevOps practitioners from around the world to the Nexus User Conference.
Hey everyone, it is Mark and Derek. We are live for the Nexus User Conference for the next 2 days. We are super excited to have everyone here.
Very excited.
There are probably some people that don't know us, so why don't we kick off with introductions? You want to tell people who you are?
Hey, I'm Mark Miller. I'm the senior storyteller here at Sonatype, and Derek and I are partners in getting the user conference going here.
Derek Weeks, I'm Vice President and DevOps Advocate here at Sonatype. Super excited about the agenda that we have ahead for everyone, and glad everyone can join us. So we're going to be live streaming here. We started 8:50 a.m. Eastern time. We're going to be live streaming throughout the day for the conference until about 6 p.m. tonight. Same schedule tomorrow with new speakers in track there. So looking forward to what we have going. So a couple of things just to shed some light on what we've been doing at Sonatype and the Nexus User Conference here is that 92% growth in the Nexus user base over the last year. We're really excited as more people come on and use our Nexus repository, our Nexus lifecycle, our Nexus firewall solutions out there. And what that means is that we have over 10 million developers and DevOps professionals who are using Nexus as part of their solutions within their environments. And we welcome all of you to this conference here where we can show you all of what Nexus users are doing with our products and how they've integrated them into their CI/CD pipelines and DevOps pipelines, as you'll see. So each day, just to kind of give you a sense of the scale of what we're doing, we're looking at over 25,000 applications for our customers within their automated open source governance program so that they can tell what open source components or containers they're using that might have license risk, known vulnerabilities, or other issues that they want to prevent from moving further down their DevOps or CI/CD pipelines. So quite a lot of scale going on, and the only way to really do that is that we need to know about a lot of components. So we've currently cataloged over 25 million components. We add about 1 million more components every day, or I'm sorry, every month that we focus on with our data team. You're going to hear more about our data team and how it helps our customers with that Nexus intelligence throughout their environments. So the exciting thing is you hear about the different customer stories that are on the agenda is that we are really at the heart of DevSecOps practices for all of these different organizations, that we're going to see how they're integrated with Jenkins, with Jira, with Splunk, with other tools that are in their environments, how they're deploying this, how they're rolling out, how they're scaling it to thousands of applications within their environments. And I think that's a really important part of the conversation that's going to happen today that you're going to hear about. Mark, any thoughts on sitting at the heart of DevSecOps?
Lots of thoughts, but we're going to hear about it for the next 2 days. The idea that security is becoming an integral part of the DevOps movement. That's the exciting part that we're going to listen to.
Yeah, so the important thing about today is you're not just showing up and listening to people presenting on YouTube here as you're watching it. That we've created a very open conference platform where not only are you here on YouTube watching this, we have our Slack channel set up, and we want you to interact with us. You can find Mark and I. Mark is the guy on Slack who's Nexus User Conference. I'm under my own name, Derek Weeks. You can find our team here across the globe that is participating. All of the speakers will be on Slack so that you can ask them questions and even ask questions of other participants in the Slack channel if you're looking for specific experiences. So that's part of the journey that we're offering you over the next 2 days, or for any of you that are watching the recordings that will be posted after this event. It's really important, and a theme that I took from one of our customers. Actually, Fannie Mae uses this quite a lot within their DevSecOps practices. This theme of run as one, and I think that's really important when we think about our commitment to DevSecOps and having development teams, operations teams, and security teams work together to deliver business outcomes that are important to their organizations. And the best organizations you'll see have really embraced this theme of run as one as they move through their own DevSecOps journeys. So with that, we have a host of different speakers that are going to join us over the next 2 days. As I mentioned, customers, partners, Sonatype employees that are going to be sharing their journeys. And in order to kind of get the best of all of those, definitely go online to our Nexus User Conference site. You should have all received the link. Hopefully you've built your agenda in Schedule so that you don't miss any of the sessions. We're not going to be on this specific channel all day, so the URLs will change of what you need to go to. And we just want to make you aware of those. All the sessions are posted on Eastern time. So depending on where you are in the world, you'll have to adjust your calendars in order to understand when we're kicking off each of the different sessions on the agenda.
Let me jump in before you change that one. For those of you that go to build your schedule, mouse over the title of the session that you want, and there will be a direct link to the correct URL for that session. So this is the window you want to stay in most of the day in order to choose which sessions you're going to watch.
Yeah. Of course, if you have any questions at all, the best way to reach us is not the Q&A windows or the chat windows that might be on YouTube, but in our Slack channel. This allows us to keep the conversation going, have a record of the conversation, allow us to share and interact with different groups rather than try and sort your way through one kind of chat window. So make sure that you're joining us on Slack. You should have the URL for joining that and any of the emails we've sent you about the conference. It's free to log in. We've made it simple to log in, where we just automatically through the Heroku app send you the login details.
And shout out to Chris Corrier again. Thank you, Chris.
Yes, for helping us set that up and get it configured so all of you can join seamlessly. As always, because we're on YouTube Live, you can rewind any of this conversation at any point in the day, so that if you've missed any sessions, if you're starting live on any session, you will be able to rewind at any particular point in time. If you're on social media, you can follow us on Twitter using the hashtag Nexus User Conference 18 or Nexus User Conf 18. We will be following our social media channels and conversations on that all day. And we are just seconds away from kicking off with Larry Maccherone here from Comcast. Larry and Mark and I have met on different occasions over the last couple of months. Larry was at our Nexus DevSecOps leadership forums in Washington, D.C. I know he and Mark also met out in San Francisco a couple of months ago at RSA when we were doing the DevSecOps days, the first DevSecOps days, where we had about 900 people there. So we've got about 1,500 people registered for today's conference, and we're all set to kick it off. And while we're on Eastern time, Larry is on Pacific time in Las Vegas. So he woke up early morning to join all of us.
My first question is, did you get tickets for tonight's game? That's the real. Are you a hockey fan?
Not a hockey fan.
Hold
but
on here. We're not getting some audio from you, Larry. Let me just make sure that we're okay. You need to turn yours on. All right, that was on our end, not yours. Good.
Can you hear me now?
Yeah, you're doing great.
Doing great. Okay, cool. So yeah, no, there's lots of T-shirts around town. It's a big deal here, but not a hockey fan myself. So.
All right, then Derek's going to slip out. I'm going to go on mute here, and we're going to turn it over to you, and we'll see you back here in about 25 minutes.
Okay, sounds great. Okay, so let's get started here. DevSecOps is not just DevOps lipstick on a traditional security pig. That's the title, the full title of this talk. I think we shortened it to just DevSecOps is not lipstick on a pig for the purposes of this conference, at least for the agenda for the conference. So what I'm talking about here is the fact that a lot of folks who are in the industry with frameworks or with tools, particularly for traditional security practices, which are mostly targeted at the security specialist groups at large organizations. That's their big customer base. Those folks are labeling their traditional tool or their traditional framework as DevSecOps without actually achieving any of the vision or accomplishing any of the goals of DevOps. And so what I'm going to talk about here today is a set of principles and concepts that apply to both tools, but also apply to culture and process. And I'm going to start with the culture and process because the rest of the day, you're probably going to hear about lots of tools. I'm going to end with tools, and that'll be sort of an introduction to the rest of the day for you here. Before I get too much into this, though, a little bit about my background. Graduated from Virginia Tech with electrical and computer engineering degree. Started my first business while I was still an undergrad at Tech. So if there's any Hokies in the fans here, so go Hokies. I grew that business to 80 employees, 20 million a year in sales. Our biggest customer was GE Power Generation. We wrote the software that controlled the power generators. So if there was a vulnerability that bad guys could exploit in that, it would be really bad. GE had about 60% market share at the time of the world's power controllers. So turbine controllers. So we would have basically exposed 60% of the world's power grid to attack. So we got really, really good at writing software with very high quality, very low vulnerabilities. That got noticed by some folks at Carnegie Mellon who were launching this thing called the SciLab. In addition to the Carnegie Mellon already hosts the CERT and the SEI, the Software Engineering Institute. So they asked me to come to Carnegie Mellon to help them launch this new program. I was the executive director of the SciLab when it started. And while I was there, I met up with a woman by the name of Nooper Davis, who's now Comcast's Chief Information Security Officer. And Nooper and I, together with another gentleman named Gary McGraw, who's now at Cigital. Cigital was sold out to another vendor. We launched a program called the Build Security In initiative with the Department of Homeland Security. I went to Carnegie Mellon because I wanted to change the world and literally change the way development gets done so that it was more secure. And with this concept of practices and principles that was fundamentally different from the way it had been done before, I found that I really couldn't change the world very effectively from academia. So I left Carnegie Mellon, went to go work for Rally Software. And the reason I did that is Rally has this database of tens of thousands of teams worth of data. And I thought that if I could prove out my framework with that data, then I could literally change the world, which is what I set out to do. And I pretty much did that. I published the largest ever study correlating practices, everything like iteration length to pair programming to specific security practices. I correlated those with performance, productivity, predictability, quality, responsiveness. And that's sort of how I'm known in the industry, as having published that big study. I'm still an active developer. I have a dozen or so open source projects, one of which gets over 200,000 downloads a month. And I feel it's really important that if you are trying to change the behavior of developers, that you actually be an active developer yourself. It's very hard for them to listen to you if you're not. So let's get into the principles and the concepts that I'm trying to introduce here now. So the basic problem is that bolt-on security by security specialists will not scale. So you just can't have enough security specialists in your organization to actually keep up with the pace of software development. DevOps makes this much worse, makes it an order of magnitude worse. And the security specialists have no idea what to do with the fact that teams are actually pushing to production multiple times a day. They used to think of themselves as a gating function. In fact, a lot of them still do. And they don't know, even the ones that realize they are no longer effective as a gating function to production, don't really know how to do it, don't really know how to help. And this talk is essentially a way for security specialist groups to transition into a different way of thinking that's much more aligned with DevOps. So the primary idea here is that the development team takes the primary responsibility for making sure that the product is okay to ship to production. That's what happens with quality now. It didn't always, but we're proposing that it happen with security going forward. So this is my favorite definition of DevOps or DevSecOps. I tend to think of DevSecOps as a marketing term, and it's really DevOps, but with the sec added, you're just sort of emphasizing the security aspects of it. But it's empowered engineering teams taking ownership of how their product performs in production, including security. And this is not the only definition that I like. There's a tools-oriented definition. There's a culture-oriented definition. This is the one that just sort of fits my framework the most. At different times, I'll refer to other folks. I'm not proposing this as the one, though. Please make sure that you don't confuse that. This is my DevOps continuum, and everyone uses an infinity loop to describe DevOps, so I have my own sort of flavor of this infinity loop. And I've grafted over the top of it a list of about 30 practices or so that you can do at various points in this continuum. And I don't have time in this 30-minute talk to walk through each of these one at a time, but they basically go through the whole life cycle one at a time. There is one that I want to stop at here and talk about for just a minute because I think it's really key to understanding the rest of the framework that I've got here. And that's this analyze and learn step. I have this thing called the defect or incident or vulnerability 3-step. And basically what it says is that we should stop thinking about defects being found or vulnerabilities being found or incidents as just an emergency you need to fix right away. It is that. Let's admit that. But it's not just that. So when you get a defect or a vulnerability or an incident like that, you should obviously fix that defect. That's step one in the 3-step. But you should also then basically try to abstract a pattern out of that and look for other places in your existing application or other applications that match that pattern and fix those. So that's step 2. And then step 3 is put in place something that will prevent you from ever introducing something like this in the future. And this is usually a tool in our space, something that would automatically look for certain types of vulnerabilities that gets run continuously. Or maybe you already have a tool like that. You have to configure it to look for this particular type of tool. Sometimes it can be training. Sometimes it can just be a process change. Sometimes it can be a wholesale technology change. So buffer overflows are much harder to do in Java than in C, C++. So if that's your problem, then maybe switch to Java. It's a long-term decision, but that's the 3 steps. The third step is usually the longest, takes the most time to actually accomplish. So this is the whole list here. Print this out, hang this up on your wall. I don't know how slides will be available, but if you reach out to me on LinkedIn, and I think my LinkedIn is at the bottom of some of these pages, I'll be glad to send anyone my slides here from today. So that's a lot of stuff. How do we get engineering teams to actually do this stuff? A lot of that stuff might be geared more towards ops teams or might be geared towards more security specialist teams. What I'm trying to do is to get development teams to take ownership of it. How do you get them to take ownership of it? Well, I have this 3-part framework that I've used in the past. I used it in the Agile world. I used it to transition teams to DevOps. I use the framework now, and I'm using it at Comcast heavily to transition teams into DevSecOps to take on the security aspect of this work. The framework is basically 3 steps, 3 parts, but the details change in those 3 different contexts that I just described: Agile, basic DevOps, DevSecOps. But we're going to talk about this one in the specific concept of DevSecOps. But the first step in the general framework is win the hearts and minds of the people who you're trying to change, in this case, developers. There's a big problem here, especially for security teams at large organizations, because there's a huge lack of trust between dev teams and security teams. It goes something like this. The dev teams are think security, they're nothing but a hindrance. They just get in our way, or they give us lots of work and they never seem to help. So we don't really like them, and they don't understand where we're coming from. The security folks think, oh, those dev teams, they can't be trusted to do anything. We have to watch them like a hawk. So there's this huge lack of trust, and breaking down that barrier is key to making this work. So I have 3 sort of tools, so to speak, to help break down that barrier. One is this thing that I've sort of grandiosely described as the DevSecOps manifesto. You can think of it as a set of core principles here. And the first one is build security in more than bolt it on. We've already talked about that a little bit. Note the structure of each of these bullets in this principles manifesto here is something more than something else. That doesn't mean that the thing that's after the more than is not valuable. It just means that the thing that's before the more than is what we're emphasizing, that we think is more valuable, at least for this conversation in this context. So build it in by the engineering teams rather than be bolted on after the fact by security specialists. Rely on empowered engineering teams more than security specialists. Implement features securely more than security features. When you say security to a developer, there's sort of a very narrow scope of things that pop into his head. He thinks authentication, authorization, encryption. But the bad guys don't necessarily tack only those aspects of your application. In fact, they're much more likely to use any input field. The input fields, the regular features that have to be there for your product to do what it was intended to do, that's what they'll attack. Not necessarily just authentication, authorization, and encryption. And so you have to actually work on making sure that everything you write is free of vulnerabilities. Rely on continuous learning more than end-of-phase gates. That's exactly what I was talking about on the continuum there with the 3-step. And build on culture change more than policy enforcement. Policy enforcement is essentially the only tool that execs and security specialists think they have at their disposal, and it's completely ineffective in getting development teams to change. Development teams will do the bare minimum checklist of things. It also takes away their agency, so they don't think about it. They just do it to get past something. And that's not what you want. You want them deciding what the right thing is to do and actually doing that wholeheartedly to really get at the problem. They also will hide from, if they know that it's a policy enforcement thing, they'll only show one of their apps to the group, and they'll hide the other apps. And it's a constant chasing around. The security specialist groups say, we find new apps every day that they never told us about. And that's because the development teams don't want to tell them about it because of the approach they're taking. I want development teams to invite me in. I don't want them to turn around and run the other way when they see me in the hallways. And that's key. Okay, so that was tool number one, is the principles. Tool number two is this thing I call the pledge. And this is hard to get security teams to commit to, but I had a lot of help. Nupur Davis, who was with me at the Build Security In initiative at Carnegie Mellon, is now the Chief Information Security Officer. She helped me to sort of get this through the security group. She has about a 400-person team at Comcast working on security. And it took me about 9 months to actually get enough people signed off on this that I could start to say this to our development teams. But if you can get your security group to say this to their development teams, this will go a long way towards breaking down those barriers and building trust. First of all, you recognize that engineering teams want to do the right thing. We trust you to do the right thing. But and you're closer to the business context and will make smart trade-off decisions between security and other risks. So this means that you can validly choose to not do something that the security group thinks you should be doing because you have other concerns that are bigger concerns for your effort at this moment. Sometimes there's bigger business risks than the security risk, and the security folks don't recognize that, but the development team who has to balance all of these are the ones that should make that decision. However, they need information in order to make smart trade-off decisions. So the role of the security team is to provide that information, to basically show them or help them to understand what the risk of this decision actually is. You can decide not to do X, but know that that will expose the company to this type of risk. Are you aware of that? Are you sure you want to make that trade-off, that you think that what you're trading it off in favor of is more valuable than the risk that you're taking here? That's the approach you should be taking. And we also, security specialists, not just need to provide information, but we need to make it really easy. We need to lower the cost or effort size of any of these practices that we're trying to get you to do. Make it dirt dog simple, and essentially become less about gating and much more about actually providing the easy button for these security tools and practices. And we want to assist twice as much with these preventative practice changes as we beg for your assistance in reacting to security incidents. And finally, and this is sort of the takeaway from this slide, we recognize we're no longer gatekeepers, but rather we're toolsmiths and advisors, and that is our role as security specialists. If you can get your security specialist team to say this to the developers, you'll go a long way towards earning their trust. So I have this other thing called the trust algorithm, and it's, we don't have time to go into it too deeply. We've actually got a blog series going on it at DevSecOpsDays.com. But basically the idea here is that trust can be optimized, that you can actually learn how to build trust in a formal way. And the formula is credibility, which is how much you know what you're talking about. And to get developers to trust you about development practices, which is what DevSecOps is all about, you have to be a developer. And so a lot of times the security specialist is staffed with very few developers. They need to beef that up, or they need to dedicate a DevSecOps transformation team with essentially all developers on it to gain that credibility. Reliability is, do you do what you say you're going to do? Make sure you track your work, make sure you get back to teams, make sure you follow up on their requests or their issues or their problems. Do you show empathy? Do they believe that you understand their other concerns, not just the security concerns? And all of that is divided by apparent self-interest. And there's always a self-interest, so this is never zero. I wouldn't be talking to you. I wouldn't be trying to get you to do something different if there wasn't something in it for me. So the key here is to emphasize the common interest. we both have stock options in this company or RSUs, and we want those to be valuable. We want to see our company stock go up. So if we get in the news for a security incident, that's going to lower our stock value. We don't want that to happen. So that's a good way to sort of take away the apparent self-interest. Oh, we, the security group, want you to do something for us. No, we think it's in the best interest of the company for you to do this for all of us, is the way you sort of minimize that apparent self-interest. So this is a 3-part framework. The first part is principles that are agreeable to the people you're trying to change. The second part is making it easy for the people you're trying to change to know what it is they're changing to, and easy for them to do it. And so I use this self-assessment approach to accomplish this. This is a facilitated self-assessment. It takes about 90 minutes, and it changes constantly based upon our capability. We only put things on this self-assessment once we've devised the easy button for doing it, or we only color code it once we've devised the easy button for it. So these gray items are things that we intend to do, but we don't have quite ready yet at Comcast. We don't have a brown belt program launched for our craftsmanship, artisanship training program, or black belt. We have our yellow belt and our green belt programs launched those. So we allow those to sort of be color coded. So what we do is we sit down with the development team for 90 minutes, and we walk through every cell in this table. And this is an example. This isn't the actual table as we use it right now. It's a subset of it at some point in time in the past. Not too long ago in the past, I updated it though. So it's pretty close. And the first row, the first cell there is 100% of the group members have been through green belt training. Or yellow belt training, sorry. And if that's true, then they color code it green. If it's not true, they color code it red. Or if it's half true, they color code it amber, or some shade of light green or some shade of light red, depending upon how close to accomplishing that they are. And at the end of this, you end up with a table that looks very similar to this at the end of this facilitated session. And the team knows not only what they do well, but what they could be doing, very clearly stated. And behind each of these is details. If you click here, you can have self-sign up for green belt training. And that's the idea, is to make it very self-service, very much easy for them to accomplish the next step in there. So at the end of this 90-minute facilitated self-assessment, we ask the teams, pick 1, 2, maybe 3 amber or red cells that you want to turn green in the next quarter. And we then commit to helping them with their plan. It's their plan. They want to turn these cells green in the next quarter, but we're going to do everything we can to support them on it. If it means we have to go manually add licenses to some tool, if it means we have to get them in contact with a certain person, if we have to set up another meeting, we facilitate all of that just for those 1, 2, or 3 goals they picked. So we don't want them biting off more than they can chew. We just want to get them on the path of continuous improvement. And we come back every quarter and we ask them to update their assessment. How did they do on their plan for the last quarter? Are there any cells that changed colors as a result of that? Are there any new cells that we've added since the last quarter? What's the new plan for the next quarter? And then we'll go back and recommit to them. This usually takes about half an hour is all it takes. And we don't need the whole team for the reassessment. We just need sort of key leadership folks.
Larry, Mark here, just giving you a 5-minute heads up.
Okay, great. We're getting close to the end here. So I'm at a 3-part framework. I'm at part 3, about to start part 3 of that. So pretty good here. The one thing to note about this table is it's not designed to get to the highest security soonest. It's designed to get them on the most gradual adoption curve. So if you look at the way the table is worded, the things on the far left are really easy to do. And they're ordered in the highest priority, of the biggest bang for the buck at the top, and then it goes down from there. So they know where to start in the upper left corner of that table and move through it. Okay, so this, part 3 of the 3-part framework is getting management involved. And And this is going through some major evolution here now, this visualization. But this is a roll up of the results of those self-assessments that we are giving to management. We're actually changing this visualization quite a bit. This was a mock-up of an earlier version of it. But for every cell in this table, there's a corresponding cell in the individual team table. And basically, if there's 10 teams in this part of the org, or if there's 100 teams in the whole org, you can roll it up at any level. And this green bar represents, the height of this green bar represents how many of the teams in this part of the org are green for this particular practice. And then the amber represents how many are amber for that. And then the white is how many are some flavor of red. And this plus 6% represents how much they've improved in the last quarter of their last year, or last reassessment, et cetera. So we're trying to focus execs on improvement by having this plus 6% and practices. Frequently, the execs only get a vulnerability report. That's they just want the red flags. And this is trying to sort of shift their focus away from this. And the way we get them hooked on this is we allow them to set goals here. So we'll recommend, we want to get to 100% yellow belt before the end of the year. Do you support that goal? Can we say that Tony, that our president supports that goal? And if they say yes, we put a line on this thing, and then we start to tell the teams the expectation is that all teams will get to 100%. So we use management to help sponsor this, to help accomplish it, one cell at a time, or maybe a handful of cells at a time in the table. So there is a tools aspect of this, and I said I would touch on it at the end. We only have a couple minutes left here, so I might not get very far with this, but I do want to show you my overlay of my vision of the tools world from a DevSecOps perspective. The very first, most important, by far the biggest bang for your buck is this tool category called software composition analysis. By some folks, it's also called dependency checkers. It's also called open source security or open source governance. These are tools, and Sonatype Nexus is a great example of that. Firewall and Lifecycle do this kind of analysis. What it's looking for is it's looking for publicly reported vulnerabilities in the dependencies that you're using. 80 to 90% of your applications are these dependencies. The bad guys know that if they find a vulnerability in a dependency that's used by 10,000 products, that's a lot more efficient use of their time than it is to try to specifically attack your custom code. So software composition analysis is an order of magnitude better bang for the buck than any of the traditional security tools that have been out there. One of those tools is static analysis. There's still a place for this. This is still valuable. I still recommend teams do this. This is sort of the next sort of bucket here. And then there's this new category called IAST, which is essentially very similar to static analysis in that it's looking for data that comes from a potentially dangerous source like a user input and gets to a potentially dangerous output like a SQL statement without going through an appropriate sanitizer. It just does that analysis of data flow very differently, does it at runtime by essentially watching how data flows through your app at runtime. Static tries to estimate at it. And the problem with that is that those estimates lead to false positives. So I basically lump these two kinds of tools together into a category I created called primary code analysis. And that is where I expect you to start. I want you to have one tool in software composition analysis and one tool in primary code analysis. And then I'll expect you to layer on more tools as time goes on. There are other tools here, and I've got them grayed out because I know I wouldn't get to them here in this talk, but the two that I start with are those two there, and then the two most important ones here.
Great, thank you.
So I have some recommendations here. They're in the slides for SCA tools and tools in general, and here's how you can reach out to me to get a copy of those slides.
Great, thank you, Larry. In addition to, after the conference is over, we're going to have a G Drive with all of the slide decks in it, so people are going to have access to all the sessions. So that's great. One of the exciting things I saw on there too, Larry, was the start of a maturity model, which I think is going to be critical for helping the whole industry move forward.
Yeah, I'm a little leery about the use of that phrase sometimes, but it is a maturity model.
Yeah, Hey, thank you so much. I appreciate it. I know that you're in a hotel room and you jumped in with us. Very much appreciate it. Thank you.
Thank you. Thank you for having me. Take care.
All right. Coming up next, we have Brian Fox. Brian, I'm going to get you on the focus here. Thank you. Brian, if you don't know him yet, is the CTO of Sonatype, but he's also the founder of the company and helped create the tools. Brian, I'm checking in with you here to make sure that everything's working with you. There you go. I see
Hey,
you
Mark.
there. Hey, how are you? Morning.
Good morning. Hey, everybody.
There you go. I can hear you good. It looks like a Tesla I was seeing there. There we go.
Oh, yeah, that's my background. That's what's that? Starman flying out to Mars in a Tesla? Yeah,
Yeah.
good picture.
All right. So I introduced you a little, but give people some background and get yourself going.
All right. Thanks, everyone. Thanks for joining us early or late or wherever you are. Yeah, a little bit of history. The co-founders of Sonatype, our backgrounds go all the way back into Apache Maven in the early 2000s. When we started the company in 2007, we were doing a lot of Maven training and consulting in those days. But the relevant part for what I'm going to talk about today is really, in that whole time, we've been the stewards of the central repository, or people may know it as Maven Central, which is the largest Java open source repository in the world. And we have now well over a decade and a half of experience in running that and dealing with the implications of having such a huge honeypot of components, and understanding what the trends are across the ecosystems. And these are the download statistics for Central. So way back when we first started the company, we were down at like 500 million downloads a year, and without I was doing training and consulting, and now last year we topped 87 billion downloads, right? And so this open source component trend is clearly exploding. More and more people are using open source every single day. It feels to some of us like, this is old hat, but clearly these numbers show that it's still increasing. And if you were to overlay the NPM downloads, for example, because the units are much smaller, the numbers are higher, but it shows a hockey stick curve, and pretty much any of the repos these days show the same kinds of thing, right? So this is all good. We're using more and more open source. Presumably, we're getting more efficient as an industry in providing value, because we've mostly not had to keep rewriting the same things over and over again. But that comes with some downsides and some unintended consequences that I'm going to talk about to try and raise awareness. So in this story, along the security vein, it kind of starts in 2013. So, a few years prior to this, we started looking into the consumption patterns of open source components from Central. Our CEO, Wayne Jackson, his background is in security, and he started looking at the logs and asking us questions like, why is it that the most vulnerable versions of component X also happen to be the most popular? Why is it that people aren't actively moving to less risky components? And so that kind of set us down a path that led to some of the products that we have today. But in the early days, when we would talk to people about security and components, there were the answers were somewhat mixed. Some people would say, well, we're not even using open source, without realizing that their developers were using Maven and consuming massive amounts of open source underneath the hood. Or if they were aware of open source, they kind of denied that there were vulnerabilities or security implications of those, and that, or it was covered by tools we have, or web application firewalls, or something like that, right? So this was the general understanding of the ecosystem in 2011, 2012. And that started to change, unfortunately, in 2013 with the first high-profile struts vulnerability that had been announced. And this one was somewhat scary and unique, because the vulnerability existed inside of the struts framework. itself, right? And so for those that aren't familiar with Struts, Struts is a fairly popular MVP web application framework for Java, right? It was very, very popular in the early 2000s, Struts 1 and Struts 2. So there are a lot of applications out there, even today, that are still built on this infrastructure. And this particular vulnerability basically was kind of the worst case scenario. It was network exploitable, was anonymously exploitable, and it allowed you basically to upload and execute code. And because the vulnerability existed inside of the framework itself, which was doing the actual processing of the request, it didn't matter what your code was. Like you could literally have a hello world application running. There was nothing you could do to protect from it inside of your own code and still get exploited. And so, you know, the Apache Struts team and the Apache security team, they do a great job dealing with 0-day, you know, disclosures. This vulnerability itself was responsibly disclosed to the team, and they did the right thing. They have a very thorough checklist of how they go and fix it, and you know, make sure the release is out there, and then they do the announcement, and the CVEs are out there, and they did all the things right. Unfortunately, there was widespread compromise of this particular vulnerability post-disclosure. Now, this one started to be exploited, you know, some number of weeks and months, and the long tail of that lasted maybe even to today, who knows? But the point being that it was after the disclosure that happened, after the responsible disclosure and a 0-day process had been followed, that's when lots of companies started to get attacked. And so this is a screenshot here of the Struts vulnerability being built right into a Chinese hacking toolkit. And so literally you didn't even have to know anything. You just like click a button, put in a URL, and boom, you've got a shell on a server running this. And so that's as bad as it can get. And so it got so bad, the FBI had to issue a field alert to their staff to let them know that lots of banks and things like that were being exploited via this vulnerability, right? So point being here, even when the responsible disclosure, even when the 0-day is done, when the project does all the things right, after the disclosure is when the bad guys pick this stuff up. And it kind of makes sense if you think of the economics of it, right? The more and more we start building on top of common infrastructure of these different components, the more and more we're basically producing a common mode failure, where a single vulnerability in a massively distributed, massively used popular framework becomes a highly leveraged activity for the bad guys, right? They don't have to sit down and figure out how to crack your website. They can go find one of these attacking kits and go search the internet for anything that is using Struts, which if you know how to use Google is not that hard to do. And so, you know, you don't have to pick a particular target. You basically are just fishing across the internet for what's vulnerable, and then you figure out how you exploit it, right? So that's what's happening as we build up on top of these popular frameworks. And so, you know, fast forward to the following year. So we've got 2014. This was when Heartbleed happened in OpenSSL, right? And we saw how prevalent that was, because that code that was affected had been out for what, a decade or something like that. And Shell Shock too. I think Shell Shock, the vulnerability in Shell Shock had been there longer than I was a developer, right? It predated me graduating. And so, you know, these things were highly prevalent across all different types of ecosystems. And I think, you know, these ones were the first vulnerabilities that kind of had names and logos attached to them, which was potentially helpful in driving awareness, you know. And so Heartbleed, the high profile attacks from Heartbleed were things like the Canadian Tax Authority getting shut down days before tax day. And things like that. And so I think these types of attacks, unfortunately, started to raise awareness in the industry that open source components had risk that needed to be dealt with. It wasn't just custom code. It wasn't just network exploits that you had to be looking at. You had to be looking inside these components. But it also kind of showed that the bad guys are figuring that out too. Right. So following year, this was the year of Commons collections, right? And Commons collections was used in lots and lots of stuff, including JBoss and Oracle Oracle's stuff, and IBM, WebSphere, I think, also had it. And so this background picture is Hollywood Presbyterian Hospital, and they actually were the victims of a ransomware attack. And after the investigation, it was found that the attackers got in through Commons Collections in JBoss and were able to then inject and execute Shodan and basically, insert the ransomware. And, they shut down the hospital. Surgeries had to be canceled. Labs were locked. Patient records were locked. People potentially had to be diverted because the emergency rooms had to be shut down, right? And we always say it has to get to the point where people die before we start paying attention. No matter what problem it is, whether it's food or car safety or airline safety. And here it is right here, right? So while we probably can't tell you the exact people who may have died from these types of attacks here or in Mercy Hospital in the UK, there are lots of studies that have shown on marathon days, for example, when ambulances have to be diverted around a marathon and they add minutes to the delays to getting patients to the hospital, that the mortality rates, 30, 60, 90 days out, are statistically significant, that shows that those types of events kill people. And so here you have a hospital who has their entire thing shut down because of a vulnerability in an application server that, by the way, had been known and announced a long time prior to when this was actually exploited. That's pretty severe, right? And we still see even several years later, attacks coming out where people are still leveraging these things. So again, the trend here in these years was vulnerabilities were announced and disclosed and fixed, and then there's this long tail where people aren't really responding, they're not updating, and that's when the attacks occur post disclosure. Then, of course, earlier last year, we had Equifax, right? And so the thing I want to point out here is that the disclosure came out on March 7th, and the investigation of what happened at Equifax showed that their probing attacks had started on March 9th. Now, it took a long time before they discovered it and worked backwards, but this was a dramatic escalation in the time to exploit or the time before exploiting post-disclosure. And so here you can see some of these trends. This comes from an IBM and Gartner report that shows how that has been going over the years. And Equifax was a dramatic escalation in that, in the severity of that, from an average of 15 days all the way down to 2 days. And so that's not a great trend. And so if we stop and think about why might this be happening, right? Let's talk about the economics of cybercrime. And I saw this at a talk earlier at Nexus from an IBM security researcher named Stephen Poole, and it kind of blew my mind. But the numbers for cybercrime as compared to the illicit drug trade were nearly equal 2 years ago, right? So in 2016, the cybercrime industry cost us $450 billion, when at the same time, the worldwide illicit drug trade was only $435 billion. That's pretty bad. And so if you stop and think about that for a moment, you think about what you see on the news, you think about the drug enforcement agencies in all of these different countries and drug cartels and all of the money that we spend as a global population on trying to fight drugs. The narrative is not the same for what's happening in cybercrime. We get upset when our social security numbers and other personal data gets stolen. It becomes headline news, and then people move on and go back. But 2 years ago, cybercrime was worth more than all of that drug trade. And so the discrepancy in the attention and the amount that we spend on that is enormous. And what's worse, the cybercrime values, or the cost to us as a population, is expected to increase to $6 trillion in 2020, right? And at the same time, the drug trade is basically just bouncing around at $435 billion, give or take, year over year over year. So we're right on the cusp of an explosion of cybercrime. and its cost on humanity. And so, at $6 trillion, that's $800 for every person on the planet. That's pretty profound. So the point being here that we're not dealing with script kiddies who are attacking our applications. These are organized, well-funded professionals that are attacking these things. And so we need to take that threat seriously. And so at the same time, we have this new collusion of potential attack vectors, right? So cryptocurrency comes in at the same time that the existing cybercrime industry is making off with tons of money. And so I was talking to somebody at one of these trade shows, talking about what we do at Sonatype and this general component attack vector, and their answer was like, yeah, that's pretty scary, but I have nothing of value in my application. Right? My application doesn't have credit card data. It doesn't have personal information data. Pretty sure we've all said that at some point in the past. But cryptocurrency really changes that dynamic in a meaningful way. Your server has CPU cycles. Your visitors have CPU cycles. Your build infrastructure has CPU cycles. And so what's happened is the cryptocurrency has basically allowed the attack itself to be directly monetized. Right, so if you think about what happened with Equifax, or even the hospital ultimately ended up paying $17 million in Bitcoin to get their data back. They paid the ransom. In some of these cases, that's chump change. But if you think about what happened with the exfiltration of the Equifax data, somebody has to go on the dark web and take that loot that they've walked away with and actually turn it into money. They have to sell it. They have to pop up somewhere and try to make money off of it. That's usually when criminals get caught, right? It's often not when they're stealing your TV, but it's when they're trying to hawk the TV or sell it on the black market. Cryptocurrency has changed that dynamic completely by allowing people to monetize that directly. And so earlier this year, there was a report. There were some vulnerabilities in Jenkins clusters that had been long known, long fixed, right? Responsible disclosure had been followed. And yet people were still running these older versions out there for a long period of time. And somebody injected miners into them. In that last report, they walked away with $3.4 million. Right, of directly monetized value coming out of this attack. They didn't have to steal anything from Jenkins to make money. And so, it sort of like, don't feed the trolls. This is exactly what's happening with the cryptocurrency. We're making it easier and easier for them to make money off of this stuff, which then further incents additional attention. And so, for the past year or so, every time a significant attack on the ecosystem happened, we were writing about it, I was blogging about it. And it kind of got to the point where I felt like, my goodness, I feel like I'm writing the same blog every single day. It's just a couple of the details have changed. And when you step back and you really look at the trend and what's actually happening, it's really kind of scary. So let's walk through this. Starts about a year ago, July 2017. There was a study that was published that talked about the credentials of publishers to the NPM repository. So 14,000% of it, 79,000 packages at the time. The credentials for the people creating those packages or authorized to write those official packages into the repository either had their credentials checked into GitHub or were subject to an easily compromised dictionary attack. So when I looked at that, what it kind of, the takeaway that I got was that we've suddenly had sort of this massive lowering of the bar of what it takes to get things into these open source repositories and the sharing and the consumption of them. But at the same time, we've made it so easy that people aren't really paying attention to their own best practices, and they're protecting their own credentials, right? It's easy to just come up with an idea, wing-ding together some component and get it out in the repository and find a bunch of users, and then you move on, and you don't think carefully about what actually it means, the care that you have, or the duty that you have to have due care over these things. And so when these developers and publishers get themselves attacked, it puts all of their users at risk. And I don't think people are generally thinking about that, both the developers themselves, but also us as an industry. We're used to consuming open source of things like OpenSSL and Apache, where these things followed great processes and they were done by very experienced developers, and so the standards and the way they go and the signatures they use are highly secure. That's not the case for most of packages anymore, and that I think is not a great trend. So not long after that that study was published, we saw within NPM, this literally happened 2 weeks after the study published, there were 40 packages out there for 2 weeks that were published. Now they weren't published in official coordinates, they were typo squatted, right? So they created packages that sounded a lot like official ones and put them out there in the hopes that people would use them. Unfortunately, it was effective. In these particular instances, the packages were collecting environment variables, and most notable for me anyway was that there were specific attempts to attack and collect the NPM publisher credentials themselves. So not only were they attacking any users of the packages, they were trying to collect the credentials to publish the official packages, and so that's pretty interesting, as it kind of belies the intent. Just about 4 weeks after that, we saw basically the same thing happen within the PyPI ecosystem. So there were 10 malicious packages, also typo squatted. In this instance, they were collecting basic info and streaming it off to a Chinese IP address. So this is your build infrastructure, your developers, and your users sending information off to China for who knows what purpose, right? So this pattern occurred within just a span of 6 weeks. Fast forward a little bit to the beginning of this year, there was a great blog on HackerMoon with this title, "I'm harvesting credit card numbers and passwords from your site, and here's how I do it." And they walk through basically talking about how they could create some relatively unimportant component, get it jammed up into something, and have everybody putting it into their website. Nobody's looking at the code, and you know, it's pretty scary. And I encourage you to go look it up and read it. But again, not long after that, we saw a new series of escalations of attacks. So this one here was a case where a popular library within Go, Go is unique in that it uses GitHub as the official repository. So all of the coordinates point to GitHub packages. And this developer, for one reason or another, decided they were done and they deleted their GitHub account. And GitHub did not prevent that same ID from being reclaimed and immediately reused by somebody else. And so what basically happened is this developer didn't really think through the implications of what happens if I just check out, what happens to my users, right? It's one thing to just simply stop publishing. It's another thing to basically hand the keys over to your factory, which is basically what happened. And so this GitHub ID was deleted and it was immediately reclaimed by somebody else. And so therefore all the social trust, all the karma, and the ability to publish new canonical versions of this particular thing happened almost immediately. And nobody really was paying attention to this. Reportedly, the person that reclaimed it was simply trying to fix a build late on a Friday night. But what if? What if this was an attack, right? And so none of the users would easily be able to spot the fact that the person who had previously been owning that ID and publishing stuff and was somewhat trustworthy had been replaced by somebody unknown, right? That is kind of scary. Then just a few weeks later in March, we saw that a popular package within NPM itself was actually directly compromised. So this was not a typo squat attack. This was an official package that had existed and was compromised and turned into a Monero miner. So everybody who downloaded and executed this package, again, developers, build infrastructures, and potentially users, if this was distributed, were now mining cryptocurrency. This was out there for a mere 36 hours. But again, since these things are directly monetizable, that was still money for whoever did it. It didn't matter that it was only 36 hours and not 2 weeks. They still made money. And so what do you think they're going to do? They're going to find more ways to do exactly that. But this was a dramatic escalation because it was no longer people poking around or leveraging mistakes or accidental things or latent issues in the components like we saw within struts and commons collections. This was the intentional injection and creation of a new malicious attack that was immediately being exploited, right? For me, that's like a whole new ballgame. And then just a few weeks after that, in May, we saw a similar thing, but this was a backdoor that had been discovered in an npm get cookies module that had been published since March. So this had been out there for several months, and it had an intentional backdoor published in it. It's unclear how or why that got there. But what's interesting is this was itself a combination of the two previous attacks that we talked about. So the get cookies module was put out there and created. It was a new module, but they probably discovered like, okay, I don't have any users. So the creation of a package and dropping it into the repo in and of itself doesn't get people exploited. But in parallel to that, somehow somebody had changed mail parser, another NPM package, and added this get cookies module as a dependency to it. And so an official package now was directly depending upon and including a pretend malicious package. There wasn't even an attempt to hide it and put code in to make it look like get cookies was being used. It was merely just included as a dependency in the package.json, right? So then that happened, and now they've got users, and all of those websites and applications that are deployed now have a backdoor in them. And then, literally, you can't make this up, within just a few weeks after that, there was a discovery of a Python module called SSH Decorator, who was stealing private SSH keys and streaming them off to Eastern Europe somewhere, right? And so this one is sort of a culmination of a number of different things. So this was an official module who was out there, who somehow got code injected in it to do it. It's unclear even today how exactly that happened. The developer of this module took a ton of heat from the ecosystem, and I think actually just basically left and unpublished this thing. So it just like went away. So it's unclear if this was intentional or if he got hacked. But what's interesting is, what better place to hide something stealing SSH private keys than a module whose job is to help you SSH to other things from Python? So if you did have tripwires of something looking at, should this application be touching SSH keys? Should it be opening ports and things like that? You would expect that behavior. It's not going to trigger any flags, right? So again, this really points to a dramatic escalation and sophistication of the attackers looking at the packages that are out there and figuring out which ones should I go after that are either going to get me, the widest audience the fastest, or are going to be the least noticed for the longest. And so who knows how many people's keys got stolen and what they're going to do with those keys next. But these things don't just, happen in isolation, right? So taken together, what we've basically seen is that we've seen a dramatic escalation in the Equifax instance of how quickly attackers go and exploit a particular vulnerability, a latent vulnerability. And by the way, it wasn't just Equifax that had been attacked within days of this. Literally just a month ago, the NSA issued a report that talked about how the US Department of Defense also was being probed within 2 days of that particular Struts vulnerability. They pointed the finger at Russia, right? So whether it's a nation state sponsored attack or just happens to be a crime syndicate in Russia, I don't think any of us will know. But these are highly sophisticated, highly motivated attackers. And so what we're basically seeing are these three things coming together. We have an increased open source usage, which is generally a good thing. At the same time, we've seen a massive lowering of the bar of the sophistication of people who are creating those packages, publishing those packages, and how diligent they are with their own credentials and making sure that they're actually good passwords and not password, and not checking them into GitHub. So that trend is happening. At the same time, we've seen and are in the midst of a massive explosion of highly funded, highly profitable crime syndicates. And we've seen the introduction of cryptocurrency, which now allows all of those attacks to be directly monetized, which means we're just now seeing the tip of the iceberg. This is just starting to happen. So unfortunately, that slide that I have that walks that timeline, it's just going to keep getting longer. And so we need to recognize this as users of open source, as the publishers of open source, as open source developers. You need to think about this. You need to think about when you get attacked personally, potentially all of the users of any of the code you've written and published also potentially get attacked. If your keys and your passwords get compromised, so do they, right? And so we have this massive amplifying effect. Every developer wants to have a profound impact on the world, and that's why we are motivated to create open source. It's awesome to be able to create something and get thousands and millions of users. It's highly not awesome when those thousands and millions of users potentially get compromised because of something you may have done or not done. And it's even worse if somebody dies because a hospital gets attacked. And so as open source developers, please pay attention to this, think about it. As open source consumers, you need to be aware that this is what's happening. You need to be able to pay attention to this and protect yourself for when, not if, these types of things will happen. And it starts by paying attention to the open source components that your developers are using, having build manifests and package manifests and bill of materials, so that when an announcement comes out that there is a new vulnerability or an intentional directed attack at a particular component, you have a chance of knowing, am I using this? Where am I using it? How do I respond? Right? That's how you have to be able to protect yourself with this. And
Brian?
so, Mark, yeah, I'm done. So,
Oh, that was perfect. Thank you so much.
all right.
Brian will
Thanks,
be
everyone.
over in the Slack channel for the next 15 minutes to answer your questions. Also, Brian, if you could load up your deck there, people would appreciate it. If you
All
can
right.
do that. And then we're going to turn it over to Matt and Wayne. Let's see. Hold on a second here. There we go. All right, Matt, you're up.
Perfect.
Okay.
Thanks again, Brian. My name is Matt Howard, and I'm the CMO here at Sonatype. And it is my pleasure today to host Wayne Jackson, our CEO, in a conversation about the Sonatype story. As many of you probably know, Wayne is a successful entrepreneur, an innovator, but most importantly, he's an engineer and a developer like so many of you. And he's passionate and committed about solving hard problems and accelerating the pace of software innovation. So Wayne, welcome, first of all. Thank you for being here. I'm curious, tell me about how you found the company and what it was like when you originally started, and how long have you been here now?
Over 7 years, believe it or not. I was introduced to the two founders, Brian and Jason Van Ziel, I guess back in 2009. I had just come off of my run at SourceFire, having taken that public, and was carpooling the kids and taking out the trash, and was looking for something interesting to do. And to their credit, they had conceived of this idea with regard to the Nexus repository, but were struggling commercially because they'd made the open source version so good. And so they were looking for someone who could come in with a different perspective and help them think through what the business could be. And I, immediately, had developed a great admiration for those guys in the team, in part for what they'd done with the repository, but really more significantly what they'd done for the industry. I mean, the Maven invention, which was a 2001 thing, you could argue transformed the way we think about software development. Instead of doing it the old way that I used to, which is writing it and cutting and pasting if you're going to borrow somebody else's ideas, this created a very orderly recipe container and dependency resolver infrastructure that enabled this whole growth of modern software development.
So when you first met Brian and Jason and Sonatype, they were early in their evolution, and one of the key assets that the company had was, among other things, sort of the central repository. When you look back at your sort of first reflection on what Central was at that time and what it's become today, what are your thoughts?
I think it's a freak of nature, frankly, especially now. But back then, it was getting hundreds of millions of download requests in the 2010 year, which struck me as a huge number. Hundreds of millions. That's a sufficiently vibrant ecosystem that there's got to be some challenge, some problem to be solved there. And that was really why I dug in, frankly. And as we've talked before, watching the patterns, being able to see what people are using and how their usage behaviors change when new information becomes available, really was the opening of the door to what we are now as a company. One of a couple of things that most struck me was how much open source was being used. A large bank might be using tens of thousands of different projects. And the other thing that really struck me was that, the disclosure of new information, especially about a vulnerability condition, had almost no impact on behavior, usage patterns. And that was really the aha, hey, there's a problem to be solved here.
So that was your reflection, at the company's sort of early sort of formation. You then sort of took that out to the market and had some conversations with some key customers. There was a number of individuals, guys like John Sembrook, that were sort of in your early formative thinking, I think influential and important. Tell me about some of those early conversations with the market, with customers who were, thinking about similar problems, challenges, and how did that go?
Yeah, so we really got lucky. We fell into some absolutely magnificent relationships with people like Jim Routh and John Sembrook, as you mentioned, who were just remarkably generous with their time, patient as we were learning as a company. And these weren't prospects yet. These were people that were just interested in helping us figure out how to solve these supply chain problems. And it was, looking back on it, it sounds strange, but most of the conversations I had in those early days were convincing people that they actually were using a lot of open source.
Yep.
I remember talking to one gentleman who's now a customer, who was one of the largest HP Fortify customers in the world, who had admittedly had no controls for their usage of open source because it just wasn't aware. Open source is one of those things that's a bottom-up phenomenon, right? So some CEO didn't come in one day and say, hey, innovation is crucial, and we're going to out-innovate our competitors by using other people's innovations, more specifically open source. That didn't happen. They might be claiming it now, but back then that wasn't the case. It was developers who saw the potential for delivering features and functionality more quickly by leveraging open source. And so it really kind of snuck up on organizations, and arguably still is. So
you mentioned the term supply chain problem. We just heard from Brian, and he talked a lot about sort of, where the world of open source is today with respect to public repositories and, various sort of hygiene and interesting challenges within that realm. What is the problem in the supply chain? Like what's the problem with the supply chain?
The most fundamental problem is that the lines of communication between producer and consumer are broken. So if you think about a traditional commercial relationship, I send Microsoft my information so that they can communicate with me. They capture my information so that they know what I'm using, what they need to communicate with me about. And so there's a linkage, right? Microsoft Tuesday, they don't just say, hey, there are these problems. They speak specifically with the folks that are affected by what they discover. In the world of open source, you've got literally millions of thoughtful, well-organized, well-run projects who are making responsible disclosures about the problems that they find, publishing on their website, pushing them to the National Vulnerability Database, and that's it. The consumers of open source may be able to monitor their top 20, top 30 most important projects, but they're not monitoring 10,000. And in many cases, because they're using components transitively, they don't even know to look for disclosures on some of those project sites. And so the challenge is that the communications actually favors the bad guys as opposed to the good guys, because the bad guys are watching and looking for those disclosures. And I noticed Brian was talking about how much more quickly they're exploiting these newly discovered problems.
So when you think about that picture of the supply chain and some of those challenges, then one would sort of imagine being able to optimize the performance of that supply chain with some patterns and practices, not unlike those that Edward Deming's sort of introduced to Japanese automobile manufacturers some time ago. Talk to me about your reflections on the supply chain problem and then the opportunity to kind of optimize it for efficiency based on your thinking.
Yeah, so I mean, it's kind of funny. I feel like in some ways we're being very innovative here by bringing supply chain principles to software manufacturing. On the other hand, we're just copying what worked in a different industry. Deming's core principles were fewer, better suppliers, the highest quality parts, traceability throughout the system, and things like andon codes that allow you to stop the process of manufacture until you solve systemic problems. And that's really all we're trying to do here, right? So help developers make better decisions early in the process, keeping a bill of materials or an inventory list of what they've used, so that as new information is learned, organizations can very quickly know how they're affected and how to respond. It's interesting. I as you know, I'm a car guy and I like sort of car analogies. But if you imagine Toyota, some random car manufacturer, allowing their factory line workers to make their own random decisions about which supplier to use, which part to use, which type of part to use, and to apply their craft however they best see fit. Any given car may be perfectly fine. But if you step back and look at the fleet of what's produced, it would be complete chaos, right? How would I affect an orderly recall when I've got 300 different types of brake rotors?
Right. Yeah, no.
And I don't even know where they live. And that's kind of a great analogy, I think, of how most organizations allow software to be developed.
Certainly, there's lots of opportunity for efficiency by making better decisions in the sort of software development lifecycle with respect to open source and third-party dependencies. The Nexus sort of developer community and the Nexus community that's sort of assembled today and tomorrow for this conversation represents, in some respects, there's the Nexus repository engineering community, and then there's the Nexus sort of IQ lifecycle kind of governance and perhaps security community. How do you view the role of a repository with respect to storing and managing and distributing binaries and artifacts into the supply chain versus something like IQ or lifecycle providing metadata and intelligence for purposes of governing the quality of those parts? How do those things fit together and play that key role?
So the role of the repository is changing in a way that I think is aligning more and more with what we do with IQ, which is to help improve developer efficiency while also creating better hygiene. The repository has historically been a caching proxy, right? Something that helped improve build performance. It was the warehouse of parts that get turned into things. I think as DevOps and DevSecOps matures, the notion of a binary version control system is going to be more and more important, right? Because I'm going to want to be able to repeat and revert maybe to any point in the DevSecOps delivery toolchain, right? So as I create a binary from parts, that should really be pushed back into the repository, and then use things like webhooks to push that along into subsequent parts of the toolchain and delivery process.
So binary version control is the next gen of the caching proxy.
In my view.
Yeah.
In my view.
And what about IQ and lifecycle and intelligence and data?
Yeah. So as people move more toward using the repository as a binary version control system, now all of a sudden it becomes a great place to interact with the evolution of binaries as they make their way to the end of the funnel, right? So the guardrails, the policies that organizations put in place that align with how they think about hygiene can be applied at those different steps along the tool chain, so that we can create better transparency. We can apply new learnings, maybe that were discovered after a developer chose a component. And so tightening things in the integrations that way.
So that's an interesting concept, the guardrails, the implication being that policy, security, hygiene, best practice can
and
be,
architecture policies. It's not just about security.
Right. Can be introduced into the software factory or into the supply chain in a way that, developers are empowered and not necessarily, put off, or in any way kind of, left to deal with friction. So there's an opportunity to, take some of these principles and empower developers to, accelerate their pace, their velocity, but do so in a manner that's sort of better hygiene.
Yeah, I mean, this is all about developer enablement. I mean, the old model, and I'll speak to security for a second, where developers create stuff that and then toss it over a wall and it becomes a security inspection regimen, where the developers view the security tribe as problem discovery people, and the security tribe views developers as problem creation people. That's got to go away. And so now, I think using the term DevSecOps, I think is appropriate because they have to be woven together. They have to be sitting next to one another. Another analogy that I like to use, one of our board members, as you know, is Steve Hills, the former CEO of the Washington Post. And he was gracious enough to give me an opportunity to watch their editorial floor. And I had this vision of, old school journalists, content creators doing their thing with
Stars.
Right, stogies and typewriters. And what I found was the media managers, the media creators, and the content creators literally sat right next to each other, actively optimizing, actively testing, right? Working
Digital
together,
media supply chain.
working together in real time to create the best outcomes for the journalist's content. And I think that's the kind of thing we have to think about for integration of security and innovation.
Let's talk about the market for a second. I mean, you've been remarkably patient. You've been with the business now for quite some time, and as you've seen sort of the evolution of things, in particular, I would suggest in the last 3 years, what's happening? Why is there this, for lack of a better term, rising tide that seems to be aligning with this concept of DevSecOps? What's forcing that to happen, or what's encouraging that to happen in the market sense?
I think in most industries, software development is now viewed as strategic. I mean, it used to be this marginal mechanism for reducing cost. Now it's arguably the last route to differentiation for almost every industry. Whether it's a media company or a financial services company or a tractor company. And so as people start to recognize the notion of software development and software innovation as strategic, they want more of it. They want it more quickly. They want it more reliably. And so I think that's why we saw the transition from waterfall development methodologies to Agile, the adoption of manufacturing optimizations like Lean, and now these concepts around DevOps, the integration of the Dev tribe and the Ops tribe, and now the security tribe, and these concepts around continuous delivery. We've got some great models. Netflix is probably the most famous of them, where it can be enormously effective and enormously disruptive. So I think,
and fueling all of that, sort of the rapid pace of innovation, the improvement in velocity, the Netflix ability to deliver innovation faster than you can blink, one would argue is an infinite supply of open source, third-party components, third-party dependencies, whether it's Java or JavaScript or pick your favorite ecosystem. There's just this massive supply of open source, and arguably that's not going to go away. How do you sort of view our sort of historical presence, sort of arguably from the Java ecosystem, from the Java community, to today, where we sort of represent kind of the reality of this polyglot world?
Yeah, I mean, we definitely cut our teeth in the Java ecosystem. One of the things that we figured out, I think, early on, was that in order to do what we do, the supply chain rigor at speed, especially continuously, then humans couldn't be in the interpretive loop, right? You had to have a sufficient degree of precision and a sufficiently reliable pool of information that machines can start adjudicating the acceptability of open source or even custom components, and helping developers make better choices. And so that took a lot of work, and it's a lot harder than most people can imagine.
But precision and accuracy with respect to the data, or getting people comfortable with the idea that you really can automate with machines and remove manual process?
Both. And it's funny, when we first started proposing these concepts, the folks who were doing the manual governance approaches were resistant and reluctant for those reasons. Now, more often than not, they're thrilled and relieved that there's actually an answer to doing this that doesn't involve tens of thousands of manual hours of inspection.
Yeah, because, I mean, how do you scale?
You couldn't.
Right.
And that's the third axis, right? Because you're right. It's a polyglot world. We have to support dozens or more ecosystems. And we have to monitor many sources of information, not just the public ones.
Can you talk, so monitoring many sources of information, not just the public ones, across many ecosystems, not just Java. That sounds like a huge undertaking and a big investment. Can you talk about the work that you and the team have done sort of to bring that value to this supply chain optimization?
Yeah, we've got some of the most extraordinarily talented people I've ever worked with in that group. Data scientists, data engineers, machine learning experts. As you know, we process 1 million-ish GitHub commit events a day. And we analyze the commit logs for every one of those, identifying potential issues that we might want to share with our customers. And so it's a huge, and I know it's overly used term, but it is a huge big data problem. I think I heard Bruce say that we have 80 million records that describe the attributes of different components across dozens of ecosystems. And the interesting thing is that I think about, from a competitive standpoint or a sustainability standpoint, is that were we to start today, not only would we have to be sufficiently talented to monitor, 1 million GitHub events plus hundreds of other sources that we use, you'd also have to build the library of all the information that preceded it, going back to the creation of Java.
Right. So it's one thing for Bruce and his team to build sort of this automated machine learning sort of engine that's able to capture and understand vulnerabilities across all of these ecosystems by monitoring all these sources, not just public sources, but many other sources. Then it's a whole nother matter for them to basically do the arguably deep research, the professional research, and the curation to kind of provide what I would submit, and curious to get your thoughts, is the real value, which is remediation. Because at the end of the day, not only do you have to know about the vulnerability, because as we said earlier, traditional tools are problem discoverers, you have to remediate. And remediation is ultimately perhaps the real value. Can you talk about that?
Yeah, problem discovery and the security industry should be embarrassed, frankly, by how little value it delivers. And this is from a guy who took a security company public.
Former
now
Fire guy.
big part of Cisco.
Sorry, Source Fire.
No, you're great. And I do still have some wonderful friendships there. But problem discovery alone is a noise generator, right? I mean, static analysis, for all of its benefits, has a reputation for generating huge amounts of false positives that some human has to go through. And then work presumably with developers to find some path to remediation the old-fashioned hard way.
Right.
But if you do the research about problem resolution as problems are discovered, then it's a lot easier to say, hey, this is how you mitigate this particular defect. Move to a newer version, move to a similar project, move to an older version maybe, change this configuration.
And back to the Toyota analogy, this is happening now at the beginning of the manufacturing process, not at the end. It's happening synchronously and continuously, not asynchronously.
Which is the concept of the end-on chord, right?
Yeah.
So, okay, let's solve this problem. Now.
Quickly.
Right. And then it will be solved from that point forward.
Right.
Not in the post-construction.
And so the downstream benefits accrue across the entire supply chain, all the way into production applications. Can you talk about this idea of rivers and reservoirs?
Sure. Credit to Jim Routh who introduced those words to us. We are, and most organizations are focused on improving hygiene throughout the DevSecOps delivery process.
Active development. So
that's the river, right? And the concept there is that unless you clean the river, you're always going to have a polluted reservoir.
Right. Yep.
And so the next focus for us, or the next incremental focus for us, will also be helping people deal with the reservoir problem, right? Because I would argue that we have a pretty close to state-of-the-art approach to solving the river issues. And now what do we do about stuff that's no longer under development, right? That may be mission critical. That almost certainly has exposures, especially in this new class of exposure related to open source and network infrastructure that isn't designed to protect it necessarily. And so getting into that collection of issues, I think, is going to be a very interesting challenge.
Well, let's peel that back a little bit, because network perimeter defense is not necessarily designed to address this issue. Web applications being sort of, probably the most popular sort of, target. according to Gartner, Forrester, pick your favorite analyst. Recently, we've seen some, very large, breaches in the public domain. Equifax comes to mind. I'm curious, how do you look at that narrative with respect to the Apache, disclosure about struts, and sort of view it from a reservoir perspective, an ops perspective versus an active development perspective?
So for the really high profile issues like struts, the folks that provide web app firewalls, next generation firewalls, intrusion prevention systems, they have rules for that, right? And so there are network protections now for struts too. The challenge for those vendors is twofold. One, as you know, 95% of the things that are in our database related to security defects are not on public sources. And so many of those vendors who don't have the focus on this part of the problem that we do are not going to have rules for those problems.
They've got rules for the head of the curve, but nothing in the tail.
Right. The other is that those technologies themselves have to be optimized, right? Even if they did have 40,000 rules that covered, 40,000 open source issues, they couldn't turn on 40,000. Otherwise, the systems would grind to a halt. And so I look forward to working with many of those vendors and educating them about new discoveries, and helping them optimize their implementations for the infrastructure that needs protecting.
Yeah. And so this then implies that as we continue to evolve, and I'm going to sort of shift gears for a second. So we've talked about kind of, the problem, the market, sort of the existing product value proposition with respect to the Nexus repository and then Nexus IQ and lifecycle. There's this logical extension that sort of says the Nexus platform kind of goes somewhere in the future. What's the high level, from your perspective with regard to the roadmap? What can you expect from the company in the next 3 to 5 years?
So I think, most of our customers, as you know, are large organizations. While our data is provided as a service, the actual implementation of the infrastructure, the IQ server, is mostly on premise. I think that's going to evolve. I think people are going to look more and more often for that implemented as a service. And one of the benefits of doing that as a service is that we become even more polyglot, right? So if you have heterogeneous repository infrastructure or competitive repository infrastructure, we still want to be able to protect the assets and the things that flow through that those tools and into the DevOps processes.
And so I guess this is just sort of the evolution of from on-prem to the cloud requires that the Nexus platform as we know it today would logically evolve to the cloud.
Yes.
Yeah.
Yes.
Well, I certainly appreciate you taking the time to chat with everybody today at the Nexus User Conference. And Mark Miller, thank you for letting us share some thoughts. We certainly look forward to answering any follow-up questions that you might have in Slack. And thank you again for your participation. Thanks, Wayne.
Thanks, everyone. And thank you, Matt.
Yep.
Appreciate it.
Okay.
All right, I'll jump in. Thank you, guys.
Thanks, Wayne. Thanks, Matt. Mark is turning off that particular channel. Our second channel is up live right now for the second stream. We are going to take a 15-minute break, and then we will be back with Michael Prescott, who's talking about the Nexus repository you don't know. This is a great conversation because as anyone knows that's been in enterprise software for a long time, you use a product, you use it daily in and out, and you probably only use 20% of the functionality that's there. And you kind of forget about the other 80% that's really powerful that some of the power users or very mature users of the product use. So Michael's going to shed some light on that. He's the product owner for Nexus Repository. So definitely look on Sketch, check out the link for those sessions, and we will be on live in 15 minutes, and we'll see you there. Bye.
I'm going to stay on for a second here, Derek, and do a little screen share so people can see how to find the sessions during the day, since we're on a break.
Perfect.
So I am going to share my screen. Let me get set up here. Thank you for doing that. For those of you that just checked in, we have different channels going during the day. So we just finished the first section in the morning. And we're on a 15-minute break, and we're going to move it over to another YouTube channel. This gives us the ability to kind of segment the sections so that you can go and see them immediately. I'm going to do a little screen share here and show you how you can actually find where the next session is going to be. Let me do that. And there's the ubiquitous infinite screen. There we go. What we're looking at here is if you go to sonatype.com, and at the very bottom of the opening page, there's a link to the conference itself. When you get to the conference page, scroll down, and the schedule is on the page there. We have just finished the sessions up through 10 o'clock. That's the channel that you're viewing right now. The next sessions are going to be in a new channel. If you'll mouse over a session, you'll see that there's a click to watch session at the top of each one of those descriptions, and that will take you to the correct channel that will be doing the YouTube presentation. So easy form, get to the schedule on sonatype.com, scroll down to the sessions that you want to watch, and mouse over the title to be sent to the correct session. All right, we'll see you back here in a little more than 10 minutes on the next channel, and see you there. Thanks.